Hey everyone, today we're going to do an example where we're going to look at a geometric series that has a common ratio r of 1/3 and an S5, meaning the sum of its first 5 terms, of 121. So first off, we are asked to find T1, the first term in that sequence. So remember, we have our formula for Sn of a geometric series as T1 times common ratio r to the power of n minus 1 all over r minus 1. Right? Now, we know r 1/3. We know n in S5. That means n is equal to 5. And so we're going to be able to solve for T1. So let's plug in the values that we know. 121 is going to go in for S5. So 121 is going to be T1, which we don't know. R, again, is 1/3, and I'm going to leave that as a fraction. So we'll have 1/3 to the power of n, but n is 5, right? That's the subscript on capital S. And so in this case, 5 takes the place of the n. And so we have 1/3 to the power of 5 minus 1, and all of this over r of 1/3 minus 1. And now it's a matter of solving for T1 algebraically, okay? So first off, we can do 121 is equal to T1 times 1/3 to the power of 5. Remember the exponent of 5, tax onto the 1. 1 to the 5 is simply 1. And 3 to the power of 5, you can use a calculator if you want, but that is 243. And we have 1 over 243 minus 1 all over 1/3 minus 1. Remember, to subtract with a fraction, we need a common denominator. I'll do that on the side. 1 whole is the same as 3/3. And so then 1/3 minus 3/3 after having our common denominator is negative 2/3. And so we can write that as our denominator, right? Next, let's go one step further. 121 is equal to T1 times, again, to subtract with the fraction, we need a common denominator. So I'm going to make the 1 243 over 243, right? And so we'll have 1 over 243 minus 243 over 243. And now, one thing we could do to make our life a bit easier is we can multiply both sides by negative 2 over 3 to cancel out the denominator completely, right? We want to get rid of it in the end anyways. And so let's multiply both sides by negative 2 over 3, right? And so in that case, the 121 here would become, let's actually evaluate that. 121 times negative 2 over 3. We can't divide it by 3, so the best we can do is write it as negative 242 thirds is equal to all of that. And now we can have negative 242 thirds being equal to T1 times, now that we have our common denominator inside the brackets, we can go ahead and subtract the numerators. 1 minus 243 is negative 242 over 243. You might notice those two numerators being the same. And so now we want to solve for T1, meaning we want to get T1 all by itself. So T1 is currently being multiplied by this fraction. To get rid of it, let's just multiply both sides by its reciprocal. So let's multiply both sides by negative 243 over 242, right? It's reciprocal. And then the same thing on the other side times negative 243 over 242. These will completely cancel out. And so T1 will be all on its own. And so over here, we have negative 243 over 242 times negative 242 over 3. Your 242s cancel out completely. And so we're left with negative times negative. So our answer is going to be a positive, right? And we have 243 divided by 3. Again, feel free to use a calculator, but that will give you a T1 value of 81. And so for part A, we have T1, the first term in our geometric sequence, to be 8. E1. Not sure what happened there. 81 is our first term in the sequence. And then in part B, let's also write out T2 and T3. So we have T1 being again from part A, 81. T2 is simply T1 times R, right, times the common ratio. And so T2 is 81 times 1 over 3, meaning that T2 is 27. And then, of course, T3, likewise, is the term before it times the common ratio. And so T3 is 27 times R being 1/3, and 27 times a third. 1/3 of 27, as you know, is 9. And so we have 81, 27, and finally 9 for the third term. And there we go. So I hope that helps. If you guys have any other questions for geometric sequences or series that you would like to see done out, please leave a comment below. And thanks for watching.